This is an informational video about transformations of exponential functions. If you recall, I taught you that an exponential function is going to look something like f of x equals a times b to the x, where a is the y-intercept and b is the constant ratio, the number that you're multiplying by. X, the variable, is up here in the exponent. Transformations is just when you are moving the graph of an exponential function around on a coordinate plane. You can tell what the transformation is going to be based on what the equation looks like. Alternatively, given the transformation, you can create the equation of the exponential function if you know the behavior of the transformation. I've made this handy little chart for you. Hopefully you have already copied this into your notes. If you haven't, please pause the video right now and go do so. Quick explanation of what I mean by in exponent and out of exponent. I'm just going to give you a quick example to write down. In the exponent, it's going to look something like y equals 2 to the x plus 1, where we are adding this number 1 inside of the exponent. So the plus 1's up here with x. If we're adding, such as this one, that is going to take our original function and shift it to the left. So our original function would just be 2 to the x, but by adding 1 to it, this is going to shift it left by 1 unit. If we were subtracting, that would be shifting our function to the right. And then when you see this negative number here, that means that if I were to make x negative, which would look like y equals 2 to the negative x, that would take my graph and reflect it over the y-axis. Remember, the y-axis is the vertical one, so that would take my graph here and flip it around. Out of exponent is going to look something like y equals 3 to the x and then plus 2, where we're tacking that on to the very end. It's not in the exponent with x, it's just at the end here. By adding 2 here, that's going to shift my graph up 2 units. If I were subtracting that 2, that would shift it down. If we have a negative in there, that's going to reflect it over the x-axis. That would look like y equals negative 1 times 3 to the x. You remember that the first number that comes after the equal sign, but is not the constant ratio, in this case a, is our y-intercept. For our original function, which would be y equals 3 to the x, there's an imaginary 1 there, and that's the y-intercept of the parent function. But here, if we are reflecting it over the x-axis, we're taking it from the top and we're flipping it upside down, which takes a y-intercept of positive 1 and turns it to a negative 1. We're going to practice this a little bit down here. I've given you the original function f of x equals 4 to the x, and we're going to transform that function in different ways, and I'm going to show you how that changes the equation. We're going to use this table to determine how to write our new equations. So if we take the graph f of x equals 4 to the x and we shift it up 3 units, I'm going to find where it shifts up, which is right here, and that tells me that I am adding outside of the exponent. So my new equation is going to look like y equals, we still have to have our 4 to the x, and then I'm shifting up 3 units, which means I'm adding 3 out of the exponent. So it looks like this, y equals 4 to the x, and then plus 3. Now for our original function, 4 to the x, the horizontal asymptote of this graph is y equals 0. But by taking this graph and shifting everything up 3 units, I've also taken that the horizontal asymptote, I've taken this horizontal asymptote of y equals 0 and shifted that up 3 units as well. So my horizontal asymptote has become y equals 3. All right, let's look at a reflection over the x-axis. I know I've got to have my y equals. Reflect over the x-axis is here, which means I have to add a negative out of the exponent. So it's going to look like this. So it's going to be y equals negative 1 times 4 to the x power. Now by reflecting over the x-axis, I've taken my graph, which has been above the x-axis, and flipped it upside down so that it's now under the x-axis. However, that hasn't changed where my horizontal asymptote is. Reflections do not change the horizontal asymptote, so it's still at y equals 0. The only thing that changes this horizontal asymptote in an exponential function is by shifting it up or down. So if we're not shifting it up or down, the asymptote's going to stay the same. All right, let's take a look at moving it right 5 units. Right is here. It is subtracting inside the exponent, so I'm going to have y equals 4 to the x, and then right was subtracting, so x minus 5 there in the asymptote. And then because I'm not moving up or down, my horizontal asymptote stays as y equals 0. All right, left 1 unit. So left is up here. Left is adding inside the exponent, so y equals 4 to the x plus 1. And again, we're not moving up or down, so the asymptote is y equals 0. All right, down 10 units. Down is here. Down is subtracting out of the exponent, so y equals 4 to the x. And then I'm subtracting 10 on the outside. And because I've moved it down, that means my horizontal asymptote's also moved down, so that is at y equals negative 10. All right, last one is going to be reflecting over the y-axis. That happens right here. That was adding a negative inside the exponent, which means that my x is now becoming negative. So y equals 4 to the negative x. Again, reflections do not move that horizontal asymptote, so it is still at y equals 0.